Okay, welcome everyone. Hello, hello. I hope you all had a nice, restful, relaxing Thanksgiving break. We have, of course, 1 week left of classes and then finals after that. So I wanted to start today just by making sure that everybody is aware of what's going on in this class in terms of the last week or so. We're almost to the finish line. We, of course, have our exam later on this week. Exam 3 is on Thursday evening. We'll talk about the exam a lot today. That's kind of our main topic for today. But I also just wanted to make sure you're aware that we have one more assignment due. That's due in your lab sections on Wednesday and Thursday. There is no studio, so you don't need to stick around. You just need to come in and get your assignment demoed. If you want to stick around, you are absolutely more than welcome to. The TAs will be in the labs on Wednesday and Thursday. They will be around to answer review questions for the exam if that's what you would like them to do. But the only thing that you absolutely need to do is make sure you get that assignment submitted, the SNP game assignment submitted. And then we, of course, have our exam on Thursday evening. I want to make sure that you're all aware that, yes, I absolutely will have the exam 3 grades back to you probably by Saturday. So I'm hoping that by the end of the day on Saturday, actually everything that needs to be graded will have been graded by then. So Canvas will be all up to date. I'll make an announcement as soon as that is the case, so that you can make the choice whether or not to come to the final exam, which is taking place on the following Monday. So you do not need to tell me if you're taking the final exam. You do not need to tell me if you're not taking the final exam. You just come show up. If you want to take the final, come show up. If you don't want to take the final, great. That will count as your drop. You don't need to tell me. It's totally okay. Totally your choice. Do want to make sure you're aware that if you do take the final exam, it's happening here in this room. Everybody is taking the final exam in this room. It won't be the whole class. It'll just be a subsection of the class. So we should have enough space in this room for everybody to take the final exam. The only exception is if you have accommodations. We'll be in touch with you about what's happening with that. You will be able to take the exam as well, of course, but there's just other stuff that we need to talk to you about. I'm trying to think of, is there anything else I need to say about that? Yeah, I don't think there's anything else I need to say about the final exam other than just making sure everybody understands that, yes, you will have all your grades back. Yes, you will know where you stand in the class, so you can make that choice about whether to come to the exam on Monday or not. Does anybody have any questions about the schedule, the logistics for the last week or so of class before we shift and talk specifically about exam 3? Any questions about the final? Any questions about grading, assignments, anything like that? All right, great. So let's talk about exam 3. For many of you, this will be the last exam that you take in this class, which is great. It is going to be very much like the other exams that you took in this class, meaning that you need to go to the same room as before. The room numbers are listed here if you need a little bit of a refresher. So you'll go to the same room that you went to take exams 1 and 2. You can bring a sheet of paper, just like you did for exams 1 and 2. You can bring a sheet of paper with you, front and back, with whatever notes you want on it, typed or handwritten. All those rules are exactly the same. The other thing I want to make sure you're aware of in regards to this exam is what's going to be on it. So this exam is going to cover the last 3 modules of material. Module 7 is when we introduce the idea of objects. What that means for you, one of the biggest things that means for you, is that the word static is no longer a thing that I want you all to be thinking about. Static should not be in your vocabulary for this exam. You will not see the word static on this exam, with one possible exception being if there's a main method on the exam sometimes, then maybe the word static will show up there. But that's it. You should not be writing static methods. Module 7, we learned about how to create objects and use object-oriented programming. And object-oriented programming says that if we want to use methods, we first need to call a constructor to create an instance of an object, and then call the method upon that object. Static methods don't use objects. Static methods, the method just exists, and we use the method by itself on its own. But that's not how we've been doing things since Module 7. So no more static things on On this exam, all non-static things are drawn out. Module 8 is when we talk about inheritance, the idea of reusing code between classes. So I have two classes, a base class and a derived class. The derived class is what's going to be doing the inheriting from the base class. We say it extends the base class. That means that it gets all the instance variables, all of the methods, everything. And there are other rules involved with that we'll probably chat about at some point today. But then Module 9, the last module material that we covered right before break, introduce abstract data types. Specifically, the two that we focused on the most are lists and maps. So those are the two that you can expect to see in some combination on the exam, are lists and maps. We also talked a bit about equality in Module 9. That's another concept that you likely will see show up on the exam as well. To help you prepare, just like for the prior exams, I have provided you with some prep materials. There's a practice quiz and the coding prep repository available just like for past exams, so I hope you've found those and started working on those. And that's my basic spiel about the exam. Does anybody have any questions about logistics for the exam or anything like that before we hop into code? Room assignments are 100% still the same. Yeah, same room as exam 1 and exam 2. The only exception to that rule is if you take the final. Again, remember the final is in this week for everybody. So, all right. As far as today goes, I have some ideas of things that I would like to talk to you about, but I always like to start by seeing if any of you have any problems or questions that you would like to see me go over. I'm happy to go over any of the code reading, the code writing problems from the prep repository. I'm happy to just answer any random questions, any general questions that you have. Does anybody have a place that they would like to begin? Does anybody have a problem they'd like to see me start working through? Yeah, go ahead, up front here. Code reading question 2, the bike. Happy to. I'm glad you picked this one, actually. I can assure you all that there will be a problem on the exam that is somewhat similar to this one. So let's take a look at what you're being asked to do here. You're given a class called bike. And this here's the constructor, right? I have some other methods, et cetera, et cetera. Down here, oh, I just told you, well, it's a main method, so static's allowed, static's okay. But here's the main method, and you're just asked, what's going to print? What is going to print? We, of course, can run this code and see, what prints. That's very easy for us to do, but on the exam, you won't have the ability to do that. So I want to work through this problem just like I would do it if I was going to work through it on an exam myself. I think it's very important to draw a little diagram to help you work through these kinds of problems. Let's start with this very first line. This very first line, if we look at the left-hand side, we're creating a variable. We're creating a bike variable. And on the right-hand side, what are we doing? What is this an example of? We're calling the constructor. What does the constructor do for us? It does initialize the instance variables, but it does that in order to create an instance of the object. So yes, you're correct. That's what a constructor does. It creates an instance of an object, and the way that it does that is by making sure that all the instance variables are properly set. So if we take a look at the bike constructor, we can see a value of 10 gets plugged in. That's going to be our maximum gear. So this is a 10-speed bike. But there's another instance variable that's set here that just our current gear is set to be 1. We start out in first gear. Everybody with me so far? So let's talk about how this would be represented in my diagram. Again, I think it's very important to sketch this out to understand what's going on here. I'm going to pull up a way that I can do some drawing. I worked through an example pretty similar to this one in class a couple weeks ago when we talked through the Module 9 material. Whoops, here we go. I'm going to start with the right-hand side. Anytime I call the constructor, anytime I see this new keyword and I'm calling the constructor, that means I'm creating a new instance of this object. Or another way of thinking about that, before this line of code runs, I have 0 bikes, no bikes, nothing exists. After this line of code executes, I have 1 bike. The constructor is going to create 1 bike for me. That's what this line of code does. So when I call the constructor like this, I will represent this half, the right half, on my diagram by typically drawing a circle. It doesn't have to be a circle, that's just what I traditionally use. And then inside of this circle, I like to say what the instance variables are. So if I refer back to the code, you can see that this got plugged in as the maximum gear, but the current gear always starts as 1. So I'll say max is 10, and the current is 1. This just takes care of the calling the constructor part. We still have this part of the line to deal with. This creates a variable, or actually we've been using another word lately to describe these. These are known as references. When dealing with objects in particular, we tend to describe them more as references than as variables. What do I mean by that? It's a label. You might hear it described as a pointer, quite literally something pointing at the object that is created. So I represent this on the diagram by quite literally drawing an arrow and labeling it 10 speed. So that one line of code, that very first line of code in the main method, is what instigated me to draw this entire thing. That's just one line of code in my diagram. The second line of code is going to look very similar though, right? You can see I'm doing the exact same thing. Before this line of code I have 1 bike. After this line of code I will have 2 bikes because I'm calling the constructor again, creating a second bike. So we would reflect that in our code in a very similar way. I would say the right hand side tells me I need to draw a circle. I need to create a new instance. And within that circle, this bike is going to have a max gear of 18. But the current gear is still going to start at the same place. It's still going to be 1. And the label for this one isn't going to be 10 speed. It's going to be 18 speed. So we would label it accordingly. All right. So after the second line of code, here's what my diagram looks like. And so far we haven't printed anything. I'm doing all this work. We haven't even printed anything yet, but that's about to change. Here we can see that I want to print the result of this. So my 10 speed is going to shift up. If I look at what shift up says to do, if the current gear is less than the max gear, which it is, I'm just going to add 1. So I will immediately update my diagram to reflect this. If I was writing this on paper, I'd just use an eraser, but I'm going to do this a little bit of a hacky way by crossing it out and drawing the 2 in there to indicate that that gear went up. And then it's going to return this value. So it's going to return 2. And 2 then is what is going to be printed out right here. This first value should be 2. If we move down to the next line, it's saying that I wish to operate the pedal method upon this 10 speed instance. So if I scroll up and see what pedal tells me to do, it says, oh, first thing I need to do is shift up. Okay, so I go up here and I shift up. That's going to bump the current gear up again. I'm now at 3. So this one's now at 3. And then once that shifting has finished, we're going to print out the current gear again. So this line of code is going to print out 3. And I'm going to go ahead and run the code at this point and just to double check myself, make sure I'm off on the right track. There's the 2 that gets printed out here. Here's the 3 that gets printed out here. So far we're on the right path. Next we see this loop. This loop's going to run 10 times, and it's going to tell 18 speed to shift up 10 times. So I'm going to add 10 to the current gear here, which turns this into 11. But then if I return back to the code and see what happens next, it says 18speed.pedal. Pedal says to shift up again, so now it's going to be 12. And then our next task is to print out what the current gear is, and we can see from the results there's the 12. That's the 12 getting printed out. Is everybody with me so far? Any questions about what I have done so far? Because it's about to go up a notch. Yes? So this takes us from 1 to 11. When I call pedal, it says to shift up again. So that takes me to 12. All right, we are now on this line right here. This line says to shift down 5 on the 10 speed, but you maybe notice that we don't have 5 to shift down. Right, I'm only on 3. So if we take a look at the code and see what's supposed to happen, right, this is not true. I can't shift down all 5 gears because I'm only on gear 3, so it says to just set it to be 1. Well, that's not hard to do. I'll just cross this out, set that to be 1, and I believe that's our next printed value right there. From this line, line 39, prints out that 1. This line right here is where things start to move in a slightly different direction. You may at first glance think that, okay, we're creating another bike here. That's going to be another circle on our diagram, right? Another arrow, and you'd be half correct. We are actually not creating another bike here. There is no new keyword. I don't see the new keyword here. I don't see the constructor, right? I am not calling the constructor. So before this line of code executes, I have 2 bikes. And after this line of code executes, I still have 2 bikes. Right? The number of bikes is not changing. I'm not creating any new bikes here. So what is this line of code doing? It is making a new reference. It's not making a new circle. It's making a new arrow. It's making a new reference. It's saying that I want to create a label called Huffy that points at the exact same bike that 18 speed points at. So if I'm updating my diagram, this is the result of that line of code. Notice I did not draw a new instance. I did not make a new circle. There's still only 2 bikes, right? But I now have 3 arrows. I have 2 references to the same bike. Yeah?
You can still refer to that as a now it's 2.
Now it has 2 names, yes. And I would like to, remind you that we do this as humans all the time. The example that I usually give in class, right, is that you all usually call me Professor Shook. But that's not what people call me at home. When I go home, they call me Dad, or they call me Doug, right? I'm not Professor Shook. Both Professor Shook and Dad refer to the same instance, me, right? Two names for the same exact person. We do that as people all the time. This is our way of doing this in code as well, having multiple references to the same object. Where things really get interesting, though, is if we kind of keep going with this example. On the next line, we say Huffy.pedal. So that means that we want the Huffy bike to shift up by 1, but really the Huffy bike and the 18 speed, it's the same bike. It's the exact same bike. They both are referring to the same bike. So if Huffy, the gear for Huffy goes up by 1, the gear for 18 speed is also going up by 1. And you can see that very clearly by doing what I've been doing, which is crossing out the old value and replacing it with the new one. I made the value of Huffy go up to 13. Well, if I follow the arrow from 18 speed, I also see that 13, right? They're the same bike. They point to the same instance. So in terms of what gets printed out, this is going to print out our 13, and there it is. But let's keep going, because this really just makes things pretty wacky. We're now saying, okay, again, notice no new keyword here, no constructor here, right? I'm not making a new bike. I am saying that I want this reference to point at this thing. So what I'm really doing is I'm crossing this out altogether. This is gone. This arrow is now gone. And I'm moving it over here. I'm now saying that 10 speed now also refers to this bike. I now have 3 references to the exact same bike. That means if I change 10 speed, Huffy and 18 speed are also getting changed. They're the same bike. They're the same bike. Think about what that means for this guy over here. We haven't actually really talked about this situation a lot, but there's no more arrows pointing at it, right? From the computer's perspective, this is quite literally garbage. And I'm not joking when I say that. That is the technical term for what this is. If you have an object with nothing pointing at it, it's considered garbage. I have no way to get to it. There's no more references to it. It's trash. It is literally garbage, and the computer will try to clean it up and get rid of any objects like that it finds. That won't be on the exam. That's just an interesting little side note. For the purposes of the exam, let's keep going with the code here. We can see that the very next line says that I want the 18 speed to shift down 7. So the 18 speed is currently at 13. If I shift it down 7, that's going to bring me back to 6, right? And then 6 is the next value that gets printed out there, since that's going to be returned from the downshift. But then when I say 10 speed shift down 7, that's talking about the same bike. So I'm going to try to shift this same bike down 7 more times, right? It's not referring to this one. It's referring to this one. So I don't have 7 to shift down. I have to stop at 1. But that is, in fact, what we would expect to see here. And then the very last line, Huffy.pedal. Again, all 3 of these references are pointing at the same instance. So when I say Huffy.pedal, it's going to shift this up by 1. That again is going to change this same exact value. Bump that up to 2, and there's the final print value. So the 2 comes from here, the 1 comes from here. This was 6, and this was, what, 13, I think. What questions do you have for me about this problem? I'm glad you asked me to do this one. If you didn't ask me to do a problem like this, I definitely would have chosen a problem like this because, again, I'm not going to make any secret of the fact that I am going to ask you a problem similar to this one on the exam. Promise. Promise, promise. Any questions? Anything you'd like me to go over again? Yeah. Different problem? Yeah, where do you want to go? What do you want to do? Sure. Yeah, I'd be happy to.
Specifically for the for loop, like inside the for loop of the map.
Okay. I believe that's the last part of the problem, so I will get to it, but I'm going to do the whole thing because I think it's a good review exercise. But we'll get to that. We'll get to that part for sure. Let's talk about this one. I like this one. This is a good problem. We want to create a dormitory class. First off, there's no inheritance going on here. And you can tell that right away. That's one of the automatic pieces of advice that I would give to you is check to see if there's inheritance going on by looking for this word, right? If you see that word extends there, you know you're dealing with inheritance. If you don't see the word extends there, you know that inheritance is not coming into play. So we don't need to worry about that. So no inheritance going on here. Don't have to worry about any of that stuff on this problem. But let's talk about what we do need to worry about, starting with this phrase right here. Try to describe different relationships between objects and what they contain. This is telling us very explicitly, this has a relationship, is telling us. I hope the red lights are going off in your brain saying, oh, here comes some instance variables, right? That's quite literally what it means when we see this has a here. It means there should be an instance variable for this thing, and there should be an instance variable for this thing. And if you scroll down, you'll see that there's exactly that. There's one for the name, and there's one for the room numbers being mapped to the different students. So let's talk about this guy for a second. Maps are very different from lists and arrays. Lists and arrays use indexes, meaning they start from 0 and they count up, 0, 1, 2, 3, etc., etc. Maps don't do that. How do maps store data? What construct do maps use to store data? They're not using an index, they're using key value pairs. Yeah, that's right, key value pairs. That's good. The way I like to think of it is that we're creating our own index, right? If we use the index the computer wants, then it's going to be 0, 1, 2, 3. If we don't like that, we can make up our own indexes, and it can be literally anything. Literally anything that we want. So in this example, we're using room numbers as our index, like strings, right? And as far as the value goes, so the room numbers are key, the value is going to be the student that is assigned to that room. So we're making a bit of an assumption here that all of the students are getting nice, cozy single rooms to themselves. I know that's not 100% accurate, but that's the assumption we're making in this particular case. And so this map represents that. This represents the room number, and this represents the student that is in that room. The first thing that we're asked to do is to create a constructor. We've already talked about what constructors are for, but we haven't written any yet today. So let's go ahead and do that. Always going to be public. Constructors always have the same name as the class that they are in. Our next big question for the constructor is, what should the parameters be? So remember, the role of the constructor is to make sure that every instance variable gets set. That means at most, I would expect 2 parameters. At the very most, one for this instance variable and one for this instance variable. Oftentimes, however, you might have fewer parameters than that. You can actually see here, I give you a big hint. For full credit, the constructor should use only 1 parameter. So think about what that means. When I first create a dormitory, I have to give it a name, but I'm essentially suggesting that this is going to be empty. There's not going to be anybody in it, right? So I can reflect that in the code by suggesting that the name needs to be our 1 parameter and gets set accordingly. Another way to think about this, consider this name is going to be different from dorm to dorm, right? I can't guess what you want to call the dormitory. You have to tell me what you want to call the dormitory. That's what I'm saying here when I'm specifying that this instance variable gets passed in as a parameter. I'm saying that you need to tell me what this name is in order for me to be able to create a dormitory. I cannot create a dormitory without you supplying me a name. For the other instance variable, we're still not off the hook. I'm not going to create a parameter for it, but I still need to do something with this. This is an object. Hash maps are objects. Lists are also objects. So in order to use objects, they have to be created. I have to make an instance of them. We've created hash maps in the past like this. I need to put the brackets over here, don't I? This is kind of how we saw us calling the hash map constructor when I introduced the concept in class the other day. The same idea still applies, but consider that we're not doing this part here anymore. This is now becoming an instance variable. So what this needs to refer to the instance variable like so. We've essentially taken, another way of thinking about that, we've essentially taken this part and moved it up here, right? So in the constructor, I don't need to say this part anymore. That part's already up here. I need to say this dot rooms is equal to new hash map. This is a tricky part. This is a part that students often get wrong. That's why I'm spending so much time on it. It's a part that students often miss. If you see a list or a hash map or other objects like this as instance variables, you still need to deal with them in the constructor, and you need to deal with them by calling their constructor, right? They're objects, so we're going to call their constructor. Are there any questions about that? I'd be happy to go over it again, repeat anything, answer any questions. Okay, with that out of the way, we can go and talk about the remaining methods. Some of these are going to be very easy. In fact, if you see any method that starts with the word get, right? I hope you don't overcomplicate those ones. Those are almost always going to be pretty short and sweet. There will be exceptions. They won't 100% all follow the same formula, but a lot of them will very much follow the same formula. If it says get name, then return this dot name. That's about as simple and straightforward as it gets. That's not meant to be a tricky one. For these other methods down here, returns the amount of rooms that are currently occupied. Okay, so rooms, that's our map. If I want to know how many rooms there are, then what I'm really asking is how big is this map? And I think it's very important to point out that I don't expect you to have all of the different things that maps can do memorized. That is not a reasonable expectation. It's kind of like standard draw on the last exam, right? If you need to use standard draw to draw some stuff on the exam, I will tell you what methods exist. Same thing for lists and maps. In fact, I think I had this open from the last review session. I'd like to show you that this is almost certainly what the last page of the exam is going to look like. I'm going to give you a list of the different things that lists can do. This one is giving methods for students. That's for a different problem. But on your exam, it could say maps down here instead if I expect you to use maps. So I will give you those methods. You do not need to memorize the different methods in lists. You do not need to memorize the different methods in maps. I will give you the methods that you need. I'm also somewhat telling you, right, that you can do everything on the exam with these methods. You don't have to pull some random method out of thin air to do what I'm asking you to. I'm telling you everything on the exam is doable with these methods. So don't worry about having to cram all that stuff into your brain. It's not worth it. It's not worth it. I will provide this reference for you. You will have references for lists and maps available to you on the exam for you to refer to. You still need to be able to use these methods properly. So, which method do I need for this particular example? So this is the entire list, right? I'm not going to give you the whole list. That would be overkill. You don't need all of these. I'm going to give you a subset of these, but one of the ones that's almost certainly going to be on there for maps is this one. Size returns the number of key value mappings that exist. So if I want to come back here and say how many rooms are occupied, that would be the same as saying tell me how many items are in my map. Everybody with me? Question?
Just a question to ask that. Shouldn't this size also include like the empty rooms, or like are we trying to get the rooms that are filled?
This is saying returns the amount of rooms that are currently occupied. So if a room is empty, I'm saying I don't want to include it. And if a room is empty, it's not going to be in the map. That's the assertion that I'm going to make. But maybe it'll help if I ask you another question, right? What am I going to see in a map, or what would I expect to see in a map if there is an empty room? I say, I go to this map and I say, tell me who's in room X, and room X is empty. The map is going to say what back to me? Is it going to give me a student? It can't give me a student, so what's it going to give me instead? You're close. Not an empty string. It's a word that starts with an N. Null. Null. So for empty rooms, they would be represented in our map as having null values. Or, anything that, if I plug in anything that doesn't exist in the map, the answer is just going to be null. Can't find it. Null. Which actually I think will help us on some future parts of this problem. If we take a look at the next one though, how do I add a student to this dormitory? I'm saying that I want, this student to live at this room number. And I need to make sure that information makes it into the map. How do I get information into a map? It's not like an array where I can say, put this student at index 2. Right? That's not how maps work. Maps use key value pairs. So how do I get information into a map? I hope you remember from the studio exercise or from looking at the reference sheet that I'm going to give you that we use the put method to get values into a map. I put key value pairs into a map. So that's what I would do here. I would say rooms.put. And Eclipse has already figured out exactly what I need. It's very smart. Right? For is occupied. This is where that little piece of info about null might come in handy. If this room is not occupied, so I'm looking to see if this particular room is occupied or not. If it's not occupied, then it's going to give me back null. If it is occupied, it's going to give me back a student. I'm not sure exactly which student. It's just going to give me back a student, something that's not null. So, one way we could actually solve this problem is to try and fetch the student at this room and check to see if it's null or not. That's one possible approach. How do I see if there's somebody living at this room? Again, it's not an array. It's not a list. I can't say, give me the value at position 7. That's not how maps work. We have to plug in a key to get the value back out. So the appropriate method for that, which again, this will be on your reference sheet, promise you it will, is this guy right here, the get method. It's the opposite of put. Put inserts things into the map, get retrieves things out of the map. So I'm going to, try to get whatever values at that room number, and if I check to see that the value is not null, then that tells me whether the room is occupied or not. If I try to get this value out and it is not null, that means it gave me back a student. That means that room is occupied. If this room is null, so I plug in the room number and it says null, that means there is no student there. That means it is not occupied. So this is one possible solution to this problem. It's not the only one, though. I think it's worth pointing out that you could refer to your reference sheet here and see that, oh, look, there's a method here called contains key that returns true if the map has the key and false if the key is not in the map. So we could actually use that as well. If we wanted to, we could say rooms.contains key. This solution would also work. I would accept either. Either approach is good. Again, though, notice that many of these methods are very simple, and it's really about just figuring out which methods from the data structure we need to utilize to accomplish the task at hand. I'm not going to promise you that they'll all be this simple, and if you've done any of these practice problems, you've probably already found some that require you to do a bit more work than this, but a good chunk of them probably will be simple one-liners. That's not unusual. This one down here is going to require a bit more work. This is the one that was asked about actually originally, since we need a way of going through the entire map and checking all of the students that are in that map, every single one. It requires a loop, requires iteration, but that's a problem with maps. That's a little tricky with maps because maps, unlike lists and unlike arrays, do not store things in order. There's no order associated with a map. So I can't just start at 0 and go all the way to the end. There is no position 0. It doesn't exist. So we have to do things a little bit differently, and you actually do have some practice code that refers to this from the exercises batch 3. Something like this will get the trick done. This is not the only way. I had a couple students come up to me after the last class and talk to me about different ways you could use loops in conjunction with maps. This is not the only way, but this is certainly a way to do it, using a for each loop. Using a for each loop like this. In fact, I'm going to copy this for each loop and tweak it to serve my needs. I want to iterate through this for each room number in the keys of the map. That's what this for each loop is saying. So the first time through this loop, this would be the first room number of the map. The next time through the loop, this variable will be the next room number from the map, and so on and so forth until it's gone through every single room number that exists in the map. So what do we want to do? We want to get the student who is living at that room, who's living in that room. That's another usage of get, right? Fetch student. And specifically what we want is that student's ID number, because our ultimate goal here is to create a list of IDs. Let's take a step back for a second. Where's this list? This list doesn't actually exist yet, so we should probably create that first. We should probably make a list for us to use. Oh, I actually don't need that part. That's a little better. Eclipse is likely angry at me because of the imports. I want to make it absolutely clear to you that you do not need to worry about imports at all on this exam. You do not need to write an import statement. You can assume they are there. That is not a thing that I want you to worry about. It is such a small, minor thing. Don't waste any brain energy on imports. What I am interested in is how do we get the ID out of here? How do we get the ID out of here? Well, I believe there's a getter for it. And if you wanted to, you could, of course, verify that by taking a look at the code and seeing that, yeah, there's a getter. There's a getter for the ID number. So we're going to get the ID, but we actually want to take this ID and stick it into this list that we made, right? So I would say I would say something like IDs.add. Something like this would get the job done, I believe. And our last step would be to return our completed list. Why are you mad at me? Oh, this is a me problem, not a you problem. The return type is a little bit off. I would not have taken points off on the exam for that. That's definitely a typo on my part. This code looks good. If you gave me this on the exam, I would love that. Full credit. Looks great. Are there any questions about how I did this, though? How I got here? Yes? Yeah, so think of the maps have key value pairs. What we're actually doing is asking you to forget about the values for a second and just think about all the keys. So what this loop is saying is that I want to iterate one time through this loop for each key that I have in the map. The first time through the loop, it'll be the first key. The second time through the loop, it'll be the second key, and so on until it's done all of the keys. What I'm doing is I'm taking those keys and I'm plugging them into the map to get the value back out, and then extracting the ID from the student and doing whatever I need to after that. I don't mind telling you all that while looping through hash maps is something that is in the prep work, I don't think I talked about it that much in class this semester. It's not a concept that I would expect to be heavily emphasized on this exam. Definitely doable, definitely a good thing for you to know. Maps will definitely be on the exam. I promise you that maps will be. But looping through maps, not my primary concern. This particular question is from, it's one of the older ones. It's from like 3 or 4 years ago. So the class was quite different actually back then than it is now. Any questions on this one? There's actually one more part down here, but any questions on this? Yeah. This one? Or this one? Yeah, no problem. No problem. There is one more part down here that I do want to talk to you about, but does anybody have any questions before I get there? Okay. So this is another example. I promise you, there will be some questions like this on your exam. These questions are trying to check your understanding about the difference between writing a class versus actually using that class. I think what can get lost, or what's actually kind of tricky to understand, it's such an abstract concept. When we create a class, right, that class is really just a template. Writing all of this code does not make a dormitory. This code does not actually create any dormitories or do anything with dormitories. It describes what dormitories contain. It describes the behaviors that dormitories can have. But the class itself does not actually create or use any dormitories. And that's true for all classes. Classes are templates. In order to use them, we have to call the constructor and then call methods upon the instance that is created by that constructor. And that's what these questions are getting at down here towards the bottom. In this main method, the very first one says, create an instance of the dormitory class and store it in a variable called dorm. So, all right, I want to make a dormitory variable called dorm. I want to create an instance of the dormitory class. This is definitely where I hope your brain is saying, oh, creating an instance, that's the constructor's job, right? That's what the constructor is for. So how do I call the constructor? Well, we always start with the word new. That's always included. Then the name of the thing that we are constructing. We're constructing a dormitory. And then if I have any parameters, I have to make sure those get included. There's just one parameter here for the name. I didn't tell you what to call the dormitory. I just expected students to use, their own dorms here. When I was a college student, I didn't go here. I went to a different school. But when I was in the dorms way many years ago, I lived in Forest Hall. That was the dorm I lived in. And that'll do it for that one. If we move on and take a look at the next one, it says create an instance of student and add it to the dorm. You can choose which room you want to add it to. Okay, so I need to create an instance of the student class. Again, creating an instance, that's constructor. That's the constructor all day. So student equals new student. What does the student constructor need to do its job? It needs an ID number. That's it for this particular example. So any ID number will do. If I wish to add this student to the dorm that was created, this is the instance that was created. I need to call the appropriate method upon this instance. And the way that we do that is by typing the name of the instance, dorm, followed by a dot, then the name of the method that we want, which in this case would be add student. We'll plug the student in here, but we have to give a room number. I expect students to make up a room number, whatever, doesn't matter what the actual room number is. And then the last one, write code to determine if a student with the ID of 1, 2, 3, 4, 5, 6 is in your dorm. How are we going to do that? Well, the first thing that we need to do probably is get a list of all the student IDs of the students that are in my dorm. So we would do that again by calling the appropriate method. I would say dorm.get student IDs. Now remember, this is going to return a list. This is going to return a list. If I wish to capture that list, then I need to make a variable for it. Oops. And then the next thing I need to do is see if this value appears within this list. This is another example of, well, let me refer to the list reference and see if there's anything on here that can help me out, and hopefully you'll see on your reference page that there's a method that lists can do called contains that tells us whether something is in a list or not. It's exactly what we need here. I would say IDs.contains 1, 2, 3, 4, 5, 6. These kinds of questions tend to trip students up a lot because, again, writing a class, that's just describing template. It's just describing behaviors. This is actually creating instances and using them, using those behaviors. Two kind of separate things. Are there any questions about either of those pieces? Yes?
How do you know student needed that variable 7 and also why did you use that?
Okay, so I knew that student needed this variable 7 by referring to the constructor. I'm assuming that this code was given to you to use on this problem, so you would have been able to see that this is how we call the constructor for the student. I didn't tell you which. Actually, I believe on the exam, I didn't tell you to construct the student. I actually just said, you are given a student in a variable called S. Insert this student into the dorm. I think that's probably more likely what it said on the exam. But, yeah, I mean, you can always look at the constructor. The 7 is just a random number I pulled out. Doesn't have to be anything in particular. Any other questions about this problem before we take a look at some other ones? Does anybody have another problem they wanted me to see, or they wanted me to go through? I have one in mind, but if anybody else has one, I'd be happy to hear about it. Yeah, absolutely. Constructor is right up here. Okay, so we haven't talked a whole lot about inheritance yet, and I definitely want to talk about inheritance because that will be on the exam. So I'm going to go over a problem. This problem actually is not in the coding practice repo. It's a problem that I just kind of made up to go over with you today. I made it up specifically for the review session. So if you're looking for this one in the coding repo, it's not there, but we'll work through it together. We'll go through this one together, and it deals with inheritance. I want to definitely talk to you about inheritance. We're going to be creating schools and universities. We're going to start with the school class. This is going to be our base class. So actually, there's no inheritance going on here. This will feel kind of like the last example that we did of completing the instance variables and the constructor. I still think that's very good review, right? So we're going to complete this base class first, and then we're going to switch over to the university class, talk a lot more about the different types of inheritance concepts that we've covered. Let's take a look at what this school class is trying to do for us. We're sort of extending assignment 7 here. We're interested in what students are enrolled at the school. So we want to keep track of all of the students that are enrolled in the school. And you can see that we gave you the instance variables. For this purpose here, the school has a name, and now I have a list of students, right? A list of students where these are going to represent the students that are enrolled at this particular school. So just like we saw in the prior example, the first thing we're going to ask you to do is write the constructor. And I gave you a big hint here. It says when a school is created, there should be no students enrolled. So that's a big fat hint that this list should be empty after the constructor is done. It does need to exist, though. There's a difference between a list that does not exist and a list that does exist but is empty. I hope you can appreciate the difference between those two things. A list that doesn't exist, I would describe as null. So a null list is different from a list that does exist and is just empty, doesn't have anything in it. A bag can be empty, right? Doesn't have to have stuff in it all the time. Let's go ahead and start piecing together this constructor. For the name, we're going to bring that in as the parameter, just like we saw in the previous example. For the list, just like we saw for the hash map, we're just going to call the constructor for it. So it's kind of like I was explaining before, right? In past examples, we've seen the whole thing in one line, but we're really just moving the declaration of the variable up to an instance variable and calling the constructor for that list within the constructor for the class that we're writing. This is just an import problem. Again, don't worry about imports. Assume that imports are all there. Assume they all work. That is not a concern for you on the exam. This should do it for the constructor. It is actually very, very extremely similar to the last one that we saw. They won't all be this similar, I promise. Just happen to pick two that are very similar to each other. For the method down here, if this student is enrolled, we want to return true. Otherwise, we want to return false. So we have a list of students that are enrolled. So I'm basically asking, is this student on this list? Hopefully that's a clue for you to go refer to your reference sheet and see that, oh, lists have a method called contains. In fact, I think we've already used it once today. Now is another great time to use that method. I can say students.contains s. Done. Don't overcomplicate it. If it seems simple, that's good. I like simple. Yes? Absolutely. Yeah, it's a great question. So there are more than one kind of lists in the world. We actually talked about two different kinds of lists. We talked about linked lists, and we talked about array lists. You can make them the same. If I wanted to put linked lists up here, that's not wrong. The problem is that if I want to switch to an array list later, I now have to switch it in two places. I have to switch it here, and I have to switch it here. But if I just call this a list, I don't have that problem. I can switch back and forth between array lists and linked lists just by changing this one spot. This makes it much easier for me to swap out what kind of list I'm using. Now, all of that being said, like, let's talk about this in practical terms too, right? I could talk to you about this stuff all day, but to be perfectly honest with you, the difference between a linked list and array list, that's not on this exam. That's not something we talked about. That is a 247 question. That's a data structures question. I didn't explain the difference between those kinds of lists. I just told you that there are different kinds of lists. What I care about on this exam is, can you drive the list, right? Can you make a new list? Can you put things in the list? Can you get things out of the list? Can you call methods upon the list? I don't care if you use linked list or array list. I don't care. They're both fine. I don't care if you put linked list up here. It's less correct. Like if you were getting paid to do this as your job, this would not be considered the proper way of doing things, but for getting full credit on an exam, sure, no problem. It'll work. Yeah. Hope that answers your question. Going back to this problem here, we're checking to see, so we did the is enrolled. Now we're going to enroll students. But be careful, we have to, so one of the things that lists do for us, we did mention this, lists allow for duplicate values to appear. I can have the same student appear on a list more than once. We actually don't want that. That's not a thing that we want here, right? Because I don't want to see the same student pop up on my enrollments more than once. So we're going to check to make sure before we add the student to the list that they're not already on that list. And you might be thinking to yourself, okay, that seems pretty straightforward. I could just say students.contains here, and that's true. That's actually 100% correct. You could say students.contains here, just like we did up above. Or honestly, if you wanted to, in fact, I would probably prefer if you did it like this. Right? If the student is not enrolled, right? Use the existing method. If the student is not enrolled, then I want to take this student and make sure they make it on the list. How do I put things onto a list? Oh, here we go. My reference sheet tells me that the add method is the way that I do that, so I'll say students.add s. So, a little bit more complicated than the prior one. We had to do an extra check. Still nothing too crazy going on here. And for remove, another very, very, very simple one, because remove is right here. So we'll wrap up our base class by telling it to remove that student. We haven't done any inheritance yet. I promise you we're about to. That's our next step, is to move on to a different class and talk about inheritance. But before I do that, does anybody have any questions about what I have done in this base class, in the school class? Yes? This is not in the coding repository. This is just an extra bonus exercise that I made up for the review session today. Yeah. Yes? Yeah, I probably can. It would help if somebody would poke me on Piazza or something so I don't forget. But yeah, I'd be happy to post this code. That's not a problem. All right, let's switch to our university class now. The instructions here tell us that a university is a school, and I think that's worth highlighting. Is a school. That's the relationship that we use to describe inheritance. If I say something is a something, I want the red flags to go off in your brain. Inheritance. There's inheritance going on here, right? Inheritance is happening. That's the relationship. We also see that reflected. This was given to you this time, although it may or may not be on the exam, right? I can see that extends keyword. That's another very big key that I'm using inheritance here. When I see extends, what does that mean? That means that everything that exists in the school class is now part of the university class as well. That includes the instance variables as well as the methods. All of that stuff is inherited from the school class into the university class. So what we need to focus on then is just what makes the university class unique. And for the purposes of this problem, we're saying that, a university can do everything that a school does, but it cares about granting degrees. Specifically, they want to know how many degrees they've passed out, right? And so it tells you explicitly that our university class should include an instance variable to track how many degrees have been granted by the institution. And unlike the previous problems that we've seen, it's asking us to write our instance variable this time. So, the number of degrees that's granted, that's probably a whole number. I don't think WashU is giving out half diplomas to anybody, as far as I know. It would be a little weird. So it probably looks something like this. Is this okay? I'd take a point off for this if it happened on your exam. It needs to be marked private. All instance variables need to be marked private. Period. I'll be looking for that. I promise you I will. All instance variables need to be marked private. I went through a whole section on this when we talked about Module 7. I'm not going to repeat all of that right now because I don't think we have enough time, but it is on video if you need to go back and review that particular piece of information. All instance variables need to be marked private. If you leave it off, it's actually public. It's the same as this. So leaving it off, not an acceptable choice. Have to have that word private there. Instance variables must be marked private. Okay. We're now asked to write the constructor for the university class. Just because we're using inheritance, that does not change what the role of the constructor is. We're creating an instance, and it's doing that by making sure that all of the instance variables are appropriately set. That includes not just this instance variable, but also any instance variables that are being inherited. So the university constructor still needs to make sure that these instance variables also get set appropriately. The way that we typically do that is by just using this constructor to handle these two instance variables, and then any additional instance variables we have, like this one, we'll take care of here. So how do I tell it to use the constructor from the school class? What do I need to say? That's where our super keyword comes in. Anytime you see the word super, I'm referring to the base class. Anytime you see the word super, I'm referring to whatever comes after the word extends. So in this case, super refers to school. Right? I want to call the constructor. I have to pass in parameters to, whoops, that's not the right class. I have to pass in the parameters to the school constructor just like it expects here. So I see there's one parameter here called name. When I call super, I have to pass in that one parameter. I have to pass in a name. Where does that come from? Well, this is a good general rule of thumb. I don't want to say it's always going to be true, but many of the times it will be true. If there is a parameter in my base class, the majority of that time, that parameter is also going to be needed here, so that I can take this and pass it to the constructor. So this line of code right here takes care of 2 of my 3 instance variables. It takes care of the name of the school. It also creates the list. It also does this. I don't see any evidence of that, right? But it's happening. It's there. It's part of this process. We are now responsible for making sure this last instance variable gets set. And it tells us right here, when a university is first created, the number of degrees it is granted is 0. I hope when you see that statement, you think to yourself, oh, it's constant, right? I do not need an int degrees here. I don't need to know how many degrees there are. I'm telling you that when a university first gets created, this dot degrees granted is equal to 0. Does that make sense to everyone? That's an important decision that you have to make when working with constructors. Do I take it in as a parameter, or is it constant? Do I just set it to what I know the value to be? Read the instructions carefully. Make sure you know which is which. I think this is a good constructor for the university class based on what we've been told. There's a method here called graduate. What it wants us to do is check to see. First, we need to make sure this student is enrolled at this university. I'm not going to give them a degree if they don't even go here. That's absurd. Next, we're going to check to make sure that they actually have enough credits. So you can see that we have to ask the student, do you have 120 credits? That's the number you need to graduate. That's the number you need to get a diploma. So let's talk about how we're going to pull that off. First thing we need to do is see if the student is on the list. And you might be thinking to yourself, okay, we've done this a couple times already. I can just say, students.contains here. And that's a reasonable guess. However, Eclipse is mad. Eclipse does not like this. You can see that it recognizes the word students. It turned it blue. It knows that students is an instance variable, but it's not happy about the way I'm trying to use this instance variable. Does anybody know why? Talked about it just a moment ago. It's marked private. This instance variable is marked private. Because this instance variable is marked private, that means I cannot use this outside of this file. I cannot refer to this instance variable outside of this file. It's not possible. Okay, well that's kind of a problem, right? There's 2 ways that we can get around this. There's actually more than 2 ways, but there's 2 ways that I think that are available to us in this particular situation for us to get around this problem. One is to use getters and setters. So, I didn't actually provide you any getters and setters here. I could have given you a getter that just says, here's the list of students, and then you could take that list and do whatever you want with it. I could have done that, but I didn't. There is no getter here for that. So we can't use that solution here. But we do have these other methods, right? What am I trying to do? I'm trying to see if the student is enrolled. I have a method called isEnrolled. It's public. So I can use this method wherever I want, right? So if I come back over here, this isn't the right way to do it. We need to say something like isEnrolled s. Or if it makes you feel a little bit better, you could even say this dot isEnrolled s. They're the same. They're equivalent. But you cannot access that instance variable. You cannot access that list directly. You have to go through the other methods. That list is marked private. The other thing we need to check is the number of credits. So, and s dot get total passing credits is greater than or equal to 120. So if they're enrolled at the school and they have passed more than 120 credits, I'm going to give them a degree. And by giving them a degree, I'm going to, increase the number of granted degrees by 1. So this dot granted degrees is going to go up. And we're going to remove that student. They've graduated. They're gone. They're leaving. So we're going to remove that student from the list of students. Again, I can't say students.remove here. I can't access that student's instance variable, but there's a method called remove that's public, and I can definitely do that. So I would say this dot remove s. Any questions about what I did there? Any questions about that one? Yeah, in the back. Could you repeat that for me? I'm not sure I follow.
So, like, you said that, like, this document will be
Uh-huh. Oh, yeah, so that's a great question. Putting this dot out in front is optional in the vast majority of cases. When calling a method, it's always optional. There's really no reason why you have to put it. I think it can still be a good visual indicator that I'm calling this upon this instance, but it's not required. When accessing instance variables, that gets to be a little bit trickier because, I kind of did it over here, right? I have two variables with the same name. If I didn't have this here, notice what happens. Eclipse gets confused. It now thinks I'm trying to assign this variable to itself. That's not really what I'm trying to do. I'm trying to assign this variable to this variable. They're two separate variables, but it doesn't know which one I'm talking about because I haven't been explicit enough. It's ambiguous. So in situations like this, it is required, right? You can also avoid that too by just making this a different name, right? And then you don't even have that problem. Yeah. Good question. Any other questions? Okay. I think we still have a little bit of work left to do over here. Yeah, so that's the graduate method. And then down here we have toString method. Remember, toString is kind of a special one. toString method gets called automatically anytime we print out an instance of an object. This one's just asking for a string that contains the name of the university and the number of degrees that it is granted. So, the simplest, most straightforward way might look like this, although we run into that same problem again. This, remember, comes from the base class. Name comes from the base class. It's private. Can't do this. Not allowed. However, if we go back and take a look at, oh shoot, there should have been a getter down here. There should have been a getter. I'm sorry. I must have accidentally deleted this in between classes because I promise you there was a getter here. Or maybe I don't know when I deleted it, but there should have been a getter here for this one that we would use here instead. This would look terrible. It's not formatted well, but I'm not grading you on that. I just said it should contain those two values. This is, this does the bare minimum of that. Would it be nicer if I put some spaces in between? Yes. But, I'd give this full points as much as it would look not great. I believe that completes this example. Does anybody have any questions about this or about inheritance or about anything at all? We only have a few minutes left. I really don't think I have enough time to go through another example. So I'm going to go ahead and call it, but if you have any questions, be happy to stick around for a few minutes and answer any questions that you have. Otherwise, you've got that assignment due in the lab section, and I'll see you at the exam on Thursday evening. Have a great week, everybody. Stay warm.